Okay guys, let's start today question number 3 of exercise 1.5, that is about the multiplicative inverse of the matrix. But if it exists. So what is the meaning of this, if it exists? In the question is written, find the multiplicative inverse if it exists. If it exists means we cannot find the multiplicative inverse of all the matrices in the universe. We can find the multiplicative inverse of the matrices which are non-singular matrices. So first we will have to check whether the multiplicative inverse of the given matrix exists or not. For this purpose we will have to check that is a singular matrix or a non-singular matrix, and how we can check? By taking the determinant of that matrix. So first we will take the determinant of this. As I've told you how to take the determinant. Directly I'm going to take -1 multiplied by 0 with the sign of -2 multiplied by 3. As the diagonal entries are multiplied with the sign of minus. So this is now 0 minus 6. This is equals to -6. That is not equal to 0. It means the determinant of A is equals to -6, that is not equal to 0. So A is a non-singular matrix. A is non-singular. And if the matrix is non-singular, then we can find its multiplicative inverse. Is non-singular matrix. So its inverse exists. Okay, how we will find the multiplicative inverse? The formula to find the multiplicative inverse is, if the matrix is A, the symbol of multiplicative inverse is like this. And the formula is adjoint of A over determinant of A. This is the formula of multiplicative inverse. If the matrix is B, then we will write multiplicative inverse of B is equals to adjoint of B over determinant of B. Here you people know how to find the determinants that we have found already. But how to find the adjoint of the matrix? How to find the adjoint? That is very easy. We just change the diagonal entries and change the sign of non-diagonal entries. Adjoint we will find here first. Formula we have written. Adjoint of A. Sorry, here we will write the matrix A. That is -1, 3, 2, 0. And what is the determinant of A? That is -6. We have already found here. Adjoint we will find here. I've told you how to find the adjoint. That interchanging the diagonal entries and change the sign of non-diagonal entries. Okay. These are diagonal entries. -1 and 0. We will interchange. In place of -1 there will be 0. In place of 0 there will be -1. 0, and here it will be -1. Change the sign of these two entries. +3 is -3 and +2 is -2. In this way we have found the adjoint of the matrix, and this is divided by -6. Now here is a division. Divided by -6, it means we will divide all the entries by -6. So here are the 4 entries of the matrix. We will divide all the 4 entries. Make first 0 divided by -6, -2 divided by -6, -3 divided by -6, and -1 divided by -6. We will simplify this. 0 divided by any number, that is 0. Both minus are cancelled. So 2 1 times 2, 2 3 times 6. This is 1/3. This is both minus are cancelled. cancel. 3 one time and 3 two times 6. This is 1 over 2. And here this both minus are cancelled. So this is 1 over 6. So this is the multiplicative inverse of matrix A. So the first thing that you will have to keep in mind, that is the singularity or non-singularity of the matrix, and then you will use the formula to find the multiplicative inverse. Okay guys, here now I'm going to solve its part 3. So part 2 is same, you can solve yourself. Part 3 again, I have to find here the multiplicative inverse, but if it exists. So to check the existence, I'll take the determinant of this. Minus 2, 6, 3, minus 9. Minus 2 multiplied by minus 9, minus 3 multiplied by 6. Minus minus plus 2 9 times 18, minus 3 6 times 18. Plus 18 minus 18 will be cancelled. So this is 0. So determinant of C is here 0. And I have told you, if the determinant of the matrix is 0, that is the singular matrix. And we cannot find the multiplicative inverse of singular matrix. So we write over here, C is singular matrix. So its inverse doesn't exist. Okay, now come towards part number 4. Here the matrix D is given. Here guys, you can see part D is 1 over 2, 3 over 4, 1 and 2 are the entries of this matrix. We'll have to find the multiplicative inverse, but if it exists. So for the existence, we will take determinant of the matrix. So how we are going to take its determinant? In the same way, 1 over 2, 1, 3 over 4 and 2. 1 over 2 multiplied by 2 minus 1 multiplied by 3 by 4. Now this 2 is cancelled by 2. Here it is 1 minus 3 1 times 3 over 4. Here there is no denominator, so that is 1. I can take the LCM here, that is 4. Now 4 and 1, LCM is 4 here. 4 will be divided by the first denominator. 1, 4 times 4, that 4 multiplied by 1, we will get 4. Here 4 divided by 4 is 1. 1 multiplied by 3 is 3. So this is equals to 1 by 4. 4 minus 3 is 1. It means determinant of D is not equals to 0. That is not equals to 0. So we can write here D is non-singular matrix. So its inverse, multiplicative inverse exists. Okay guys, now we are going to apply here the formula. The formula of multiplicative inverse is adjoint of D over determinant of D. So first we will take the adjoint. Determinant we already have, we 1 and 4. Adjoint of matrix D is 1 over 2, 1, 3 over 4 and 2. Its determinant is 1 by 4. So I will take its adjoint. That is, I will interchange the diagonal entries. Here it is 2. Here it is 1 by 2. I will change the sign of non-diagonal. Both are plus. They will be changed into minus. This is now minus 1. And that is minus 3 over 4. And this is divided by 1 by 4. Okay, now guys, we have applied the formula, we have put the values, we have taken adjoint. Now you can see the matrix is divided by 1 by 4. It means we will divide all the entries of the matrix by 1 by 4. So here I am going to do this. This is not difficult, only complex. So 2 is divided by 1 over 4. Minus 1 is divided by 1 over 4. Minus 3 over 4 is divided by 1 over 4. And 1 over 2 is divided by 1 over 4. Now we'll simplify. If there is division, we can change the division into multiplication and take the reciprocal of the next expression. So 2 is the numerator. I will write as it is. Division is changed into multiplication. 1 over 4 will be now 4 over 1. Here this is minus 1. Division is changed into multiplication. 1 over 4 is 4 over 1. Same like this, minus 3 over 4 is the numerator. Multiplied, because this division is changed into multiplication. 1 over 4 is now 4 over 1. Here that is numerator is 1 over 2 multiplied by 4 over 1. Now you can see which same factors we can cancel here. Here 1 has no value, 4 can be cancelled by 4. And here is 2. 2 how many times is 4? That is 2. 2 times is 4. So now what is left over here? 4 2 times 8 minus 1. 1 multiplied by 4 is 4 minus 3. And here 1 2 times 2. This is the multiplicative inverse of matrix D. So matrix D has the multiplicative inverse 8 minus 3 minus 4 and 2. The only difference is here that here the determinant is in fraction. When you will divide the determinant, you will change the division into multiplication and then you will do the cancellation to make the entries simple. Thank you.